attendance. So if you register this class, make sure that you show up and sign on that sheet. I believe ITE will circulate that sign-up sheet every seminar. So I've already sent you an email about how exactly you're going to be graded based on that. The grading criteria are already on that email. If you have other questions, please let me know. And I just want to know that you guys are encouraged to interact with all speakers, so I'll consider to give you a plus. On top of the grade, if I notice you're active in questioning, in asking questions, and interacting with other speakers. So today, we're very pleased to have our alumni and also old friend, Mr. Bhide. So Mr. Bhide obtained his master's degree from industrial engineering at USF, and he's currently the chief traffic management engineer and smart cities program manager at the city of Tampa. And his duties mainly include oversight of the city's traffic management division, including traffic management center, traffic signals, operations and maintenance, traffic counts, capital improvement projects, intelligent transportation systems, and a number of other wonderful things. He has been supporting our research and education for a long while, so we're very happy to have him here. And let's welcome for his talk about smart cities.
Well, thank you all and good morning. It's really great to be here. Lots of familiar faces, which is great. And as Dr. Shah mentioned, I'm a former USF Bull myself. Well, USF Bull for life, so go Bulls. Also worked at CUTR as an RA, and really honored to be here today and talk to you about smart cities. So I do hope this is an interactive conversation, so feel free to jump in and ask questions. But as Dr. Shah mentioned, I work for the city of Tampa. I manage the city's traffic signal system, street lights. We have over 40,000 street lights. We're converting to LED. We'll talk about that. And more recently, the city's smart city program. So just generally, what's your understanding of smart cities? All right, well, I'll give you the easiest definition that actually Dr. Bertini...
Everyone gets a minus for participating.
So, quite simply, I would say smart cities, or a smart city is a city that leverages technology to improve quality of life. What that looks like, where things are moving are different depending on the metro area, how they're organized, and what kind of solutions and what kind of funding they have. So we're going to talk a bit about that today from Tampa's perspective and how we see smart cities unfolding in our region out here. We'll take a look at the context in which a smart city exists. What are some of the key technologies that are driving a city to be smarter? Some thoughts on how to develop a framework for a region. So if you're a practitioner, you're trying to put a framework together for a region, what do you look at, and what have we looked at as the city, and some of our concepts and some of our projects that we're hoping to get funded, and some that we're working on right now. So let's get right into it. So the context in which a smart city exists, the three main driving factors I would say are urbanization, demographics, and climate change. We're urbanizing as a country, as a world. So by some accounts, by the year 2050, 3/4 of the world's population might live either close to or in highly urbanized areas. That's a rapid rate of urbanization that we haven't seen as a civilization in a while. And what's happening is, in our context here in Tampa or the US generally, the two behemoth generations, one, most of you, which is millennials, And boomers, mainly empty nesters, are moving to downtown areas, to highly urbanized areas. Both of these groups display similar characteristics and behaviors in terms of smartphone adoption, open to technology, being part of the sharing economy. And this is happening with both of these major generations. I mean, and that's transforming the way we look at government services, city services, especially in our urban areas. So you're seeing a lot more shared mobility, a lot more demand for point-to-point services, app-based, rather than fixed route services through shuttles and things like that. So urbanization has a major impact. Demographics, we talked about both millennials as well as boomers. And millennials are attracted for the job opportunities that urban areas provide, social opportunities, and just a better environment to live, work, and play. Boomers are attracted to the cultural opportunities, museums, things like that. They want to downscale their lives. They want to drive lesser. They want to walk more to shop, to services, and things like that. And finally, climate change. So that's impacting all of us, right? Not a myth. It's very real. And I'll give you an example right here in Tampa. So Bayshore Boulevard, how many of you have been to Bayshore Boulevard? Great. It's beautiful, right? You know, on the water. But what we're seeing is in the last 5 years, the intensity of storms within a season has increased. The overall rainfall is more or less the same, but the intensity of storms is higher. And what that means is, right around high tide, if you have enough rain, it overwhelms our stormwater system, and there are at least 4 spots on Bayshore Boulevard that flood. Now, where does smart cities come into this? If we had sensors that measured ground saturation, we know that if we have more rain, this facility will flood. And then once the flood comes in, today what we do is we have reactive measures of rerouting traffic, putting in product, cones, signs, things like that. If we could do it an hour before the flooding is anticipated, we'd be able to save a lot of money, time, and headache, frankly. Safety is a major aspect in Tampa's context. As a region, generally, urban areas in Florida have not done very well when it comes to bike and ped safety. All 4 major cities in Florida are in the top 10 unsafest cities for bicycles and pedestrians. We do need to change that. We've moved the needle on that. So just in the last couple of years, we've added close to 100 miles of bicycle lanes. A couple of years ago, we opened our first signalized, median-separated cycle track along Cass Street. We're reducing cycle lengths. We're doing cycle reductions in our signals. We have increased yellow times. We've adjusted pedestrian crossing times. And every time we upgrade a facility, we try and reduce crossing distances and increase pedestrian safety. The arc of infrastructure is long. You're probably going to see the effects of this over the next 4 or 5 years, but we're definitely moving in the right direction. And that direction is consistent with the smart city as well, where you're moving from single occupant vehicles to more of shared mobility, more active transportation, walking, biking, and so on. So it all kind of connects together. And finally, technology. So recent technological developments are making all of this much more possible. So let's take a look at technologies. You have IoT, Internet of Things. It's a buzzword today. Everyone's talking about IoT. In essence, that is a sensor or a device or a piece of equipment that communicates over the internet to a center. So you have the sensor, you have the network, and you have the analytics, computing, traffic management center. Some of you have visited the traffic management center, and I would welcome all of you to come and visit. If you wanted to do a field trip one day, we'll show you around what we do at the center, how we manage the signals, and why it's a logical clearinghouse for a smart Tampa. So you have IoT, and by 2050 we might have more than 20 billion connected devices informing us about what's going on in the world And that's good data that we can leverage to improve services and also save some cost along the way. And we'll look into that as well. You have advanced cellular services, right? 5G, the standards kind of coming together, much faster than 4G, way lesser latency than 4G. Current 4G latency from point to point in a service via a cloud-based platform is about 4.5 seconds today. We know this because we're doing connected vehicles using that. We'll look at that as well. 5G, you're looking at 40, 50, 100 millisecond latency. At that kind of latency, we can leverage cellular networks to deliver both safety and mobility services. The difference there is now we don't need to own and lay out our own fiber or build our own networks. We can leverage networks that are also used for commercial uses, for public uses. And that saves cost as well. That really allows us to do a lot more with a lot less. Processors are getting faster, right? Sensors are getting cheaper, processors are getting faster. Excuse me. You can do more with the same device now than you used to be able to. Those of you who can remember the first iPhone, it wasn't that long ago, like 10, 11 years ago. It was basically an iPod that could make calls at that point, right? And now the iPhone does so much more, and so does the Samsung, if that's your platform, and so on. You have connected and autonomous vehicles, another buzzword. There's a real possibility, and Tampa is one of 3 test pilot sites right now across the country for connected vehicle technology. To put it simply, connected vehicle technology is where a vehicle speaks to the infrastructure, which also speaks to pedestrians and bicyclists, so that everyone that participates in a transportation system has complete awareness of what's going on within the facility or what's coming at them. This connectivity can be leveraged to improve safety, to improve services, to predict actions of other vehicles, and to improve traffic flow in general. So that's the advantage there. With autonomous vehicles, of course, that's a paradigm shift. But the technology is pretty close to being implemented. It will be implemented in limited fashion. Like we're doing along Marion Transit Way later this year, we'll have a autonomous shuttle running from the Marion Transit Center in downtown all the way down to the Whiting Garage. It impacts a large number of jobs, residents, and just makes for a better environment. It's also transit-only corridor, so it's a good, safe entry into this space to understand where the community is at with interacting with this mode of transportation, which is something new, how efficient it is, and what are our options of servicing demand that is currently not being serviced through this new mode of transportation. So that's some of the other stuff we're looking at. And then there's AI and machine learning. You have better algorithms today between clustering and predicting that will allow us to tap into the sensors that we spoke about before, get data from these sensors, from other data sources, and inform everything from traffic operations to managing our water meters, to managing airports better, to managing healthcare better. Because when you talk about transportation, you also have to be mindful of the other 2 legs of that stool that complete the circle, if you will, and that's public health and energy. So all of these tie in together. And finally, crowdsourced data. We talked about sharing economy. So anytime you use an app, if that data can be crowdsourced to deliver better services, like we do, we get data from Waze. How many of you use Waze out here? It's a great platform, right? Very convenient. Every time you use Waze data, or if you have the app on, or if you have Google Maps on, you're a data point moving from point A to point B in space. That's captured by Waze's platform, and they provide that data to municipalities, and we see performance of corridors over and above the sensors that we already have, which are mainly at intersections. This allows us to know what's going on bridges and things like that. And it augments existing sensors like cameras. So crowdsourced data is really going to change how we interact with the world and how we deliver services as well. Any questions so far? Great. So moving on. Let's look at how to develop a framework, right? You're a practitioner, you're a university, you're a private corporation, and you want to develop a framework for a region. In Tampa's case, this started, and that's true for many other cities, with the Smart City Challenge. So USDOT had a challenge that ultimately Columbus, Ohio won. They proposed some really good projects, as did 77 other cities that weren't really excited about not winning necessarily, but it did start a regional dialogue within communities. So we collaborated with USF, we collaborated with the port, the airport, the county, and several other local agencies to really sit down and say, hey, what do we need in the context of all of these changing technologies, and how do we improve our services? And some insights from that were, to develop a good framework, really, you do need to start with regional leadership. So you've got to go to the mayors and county commissioners and, excuse me, and local leaders and get their support. You have to have that commitment and support at the top before you start deploying projects or piloting projects and things like that. To garner regional leadership, you really need to have a clear benefits narrative, which is kind of similar to what we do when we're working on our thesis or something. Your problem statement, it needs to be really sound, needs to be very clear. When it comes to leadership, it also needs to speak to the common person. So your benefits narrative also now becomes your political narrative. So for practitioners, it's a problem statement that you work off of. For politicians, it's something that they pitch to the community. And it could be a very simple pitch. For example, persons with visual disabilities should be able to walk comfortably through downtown Tampa. That's one of our problem statements. Now, if there's a technology solution for that, you address it that way. If there are other solutions, hard infrastructure, whatever it is. But that's a very simple problem statement to work off of. Leverage generalists when you're developing your plan. So generalists are folks that are non-technical, that look at community issues and see things from like a 30,000-foot level. So not necessarily just planners. In our case, the mayor's aides, community relations folks, AARP, they provided these generalist insights, and they're great. I mean, you put 10 engineers together, and they'll solve a specific problem. But how do we address this broader issue requires a broader participation from the community. So generalists are great for that. The key to a smart city is public, private, and academic entities coming together to deliver these solutions. It's a continuous learning process. Nobody really knows how ultimately this smart city will be delivered. It's not the same as traditional infrastructure. So we need everyone at the table. We need a living lab right here at USF. Another living lab becomes downtown Tampa. And you should be willing to take risks and fail and succeed. All of it, but risk-taking is something traditionally local governments haven't done, and they do need to get into a little bit more. We talked about community engagement, but public-private partnerships, P3s. In my opinion, a smart city will not be realized until public and private entities come together and academic entities come together. And here's why. The main reason is technology. Technology changes every 6 months. It takes us almost a year to procure a large project. So there's no way that government is going to keep up with changing technology and deliver better services or leverage that opportunity, whereas the private sector is more nimble on that. And a partnership is ideal to really realize this vision and take it forward. consider operations and maintenance. And that's important, right? Because projects are really sexy. There are ribbon cuttings, and the politicians show up. It makes media and all that. And then 3 years from that time, how's that facility doing? How's that technology doing? How's that implementation doing? That needs to be baked into all of the planning up front. So considering O&M is extremely important. The state is aggressively working towards that, as is the federal government, through the Transportation System Management and Operations Initiative. It's called TSMO, and it's exactly about that. When you plan, consider what happens after the project, which is in essence your systems engineering approach. How many of you are familiar with the systems engineering V-chart? Right, so look it up. It's very useful. So basically, the gist is that you start down with a concept, kind of similar to, again, developing your thesis, and then you do your literature review, then you do, in engineering, you do your design, you go to implementation. The minute you start implementation, the feedback that you were getting from your literature review or your design and similar processes, now it becomes a feed forward. It goes back and you change your planning based on what you're seeing with your operations. You complete that circle, if you will, between planning and operations. And really that's what it's all about, to consider operations and maintenance. Streamlining procurement. Government is slow. It takes a while to procure anything. We really need to get to a point where we can be more nimble about these things. I talked about, adopting pilot projects. We call it the city as a lab approach in Tampa. In essence, what that means is if there's a good idea out there, rather than putting it in a report and a plan, let's just put it out in the field in a small way. See if it works. And if it works, you grow that idea. And if it doesn't work, well, you move on. But you take that risk. It's very important that public, private, and academic entities partake in the innovation process. For too long, as cities, we've been consumers of innovation, but we've not participated in it. And there's some unique advantages to a city being part of that innovation process. And so we're doing, I'll give you a few examples as we move along. This particular item, vulnerable communities, persons with disabilities, veterans, the people that are economically challenged. A smart city has the potential to bring these folks into the fold, who are our vulnerable communities here in Tampa. We have a very high population of homeless people here. We have a lot of low-income folks. We have a lot of folks with disabilities. And we had the persons with visual disabilities use case. Technology can address all of these folks if we bake it into our planning process. And the opportunities are there, as you'll see down the road. Tackle few big needs initially. That will really move the needle, get community support. In our case, some of those initiatives are the connected vehicle pilot. This is a technology that is ready to go today. I think there's some discussion about what communications network that platform will be delivered on, but the utility of the solution itself is very well established. So we're one of 3 communities, along with New York City and Wyoming DOT, in the country that's deploying CV technology, connected vehicle technology, and informing the state of the practice around the country. And then finally, be bold and think transformation. And this isn't business as usual. And right now, where we are at with smart cities, we're looking for any and every idea. And if it seems viable, if it's means tested, it works well, then we're going to deploy it. And if it doesn't work in deployment, then we move on. But let's think transformation, not just enhancing what we have today, but changing the way we do business as usual. Let's look at our concepts and some of the things that we're doing. Of course, these concepts are in the auspices of the goals that are listed. we do want, as a community, to have a competitive advantage. We want to get some of these projects done first. We want some of these projects to get done right so that we get recognition. This will attract talent. Hopefully this will keep most of you in this room, in this community, and participating in it through your areas of expertise. We want to improve bicycle and pedestrian safety, and there's no two ways about it. FDOT, Hillsborough County, the city of Tampa, you go across the bay, St. Pete, Clearwater, everyone has this as one of their top 3 priorities, partly because we're really bad at it. I mean, and we need to get better. So, user-focused mobility, that's that transformation part, right? Traditionally, we've had buses that go from one station to another, and you've got a schedule and so on and so forth. Now, and even here on campus, you've got bike share. It's user-focused. You pick it up when you want it, you drop it off when you want it. The same thing, you go to downtown Tampa, you have the Downtowner shuttle. And that's an app-based, point-to-point service. It's an electric shuttle. Right now, it looks like a golf cart, a stretch golf cart, if you will, but very soon they're converting the fleet to Chevy Bolts, with a B, which are smaller vehicles but much safer. It's a very popular service. It's very popular thanks to a whole bunch of UT students, very soon to be USF medical students as well, and generally the two generations that I spoke about, millennials and boomers. They're using this service to the point where wait times are like 40 minutes. So guess what? People adapt to these things. So our public relations director, she lives in downtown Tampa, and what she says is she wakes up, she orders the Downtowner, and then hops in the shower. So by the time she's ready and she goes downstairs, it's 40 minutes and then it's available. These are good problems to have because this means that we need more of this service. So there's clearly more demand than there is supply. We just have to figure out the best business model. Today, this service is free, and any service that is free, the demand for it is what? Infinite, right? I mean, because the service is free. If it's valuable, the demand's infinite. So that's where we're at right now. For the first 3 years, the service is being funded in a collaboration between the city and the state, being run by a private entity, and the hope is that they will then take this business model and run along with themselves. Congestion mitigation. Everyone's been stuck here in traffic. I don't hear about it enough in my job, so we know what congestion is. It's pretty bad, and it's getting worse as we grow. Vulnerable communities, climate change sustainability, and port and airport security. Especially with robotics, with unmanned vehicles and things like that, it opens up more and more opportunities to enhance port and airport security. Just a quick plug for Port Tampa Bay. By sheer weight, by tonnage, we are the largest port in Florida because we ship a lot of phosphate out of Tampa. By container size, it's Jacksport, which is Jacksonville, and then Miami, and then Tampa. We're also the largest port. But what's unique is high tonnage of phosphate, which is hazmat, basically, and a very large port across a wide geographical area, all the way from Southeast County by Apollo Beach and Cockroach Bay to downtown Tampa. So unmanned aquatic vehicles with sensors on them could potentially monitor the hazmat situation in the water and also look for security threats. So that's one use case that we'd identified through our Smart City Vision for port security. So these are our goals. Here are our stakeholders. CUTR is a major stakeholder. Thanks to Dr. Bertini, we're in the process, actually it's been approved on both sides, of signing a memorandum of understanding between the city and the university for deploying smart cities projects and supporting smart cities research. This is very similar to what the city of Pittsburgh did with Carnegie Mellon. Their focus was more on AI, we've kept an open focus. We want all three branches of that smart city stool, energy, public health, transportation, to be addressed through this partnership. Of course, other partners, public partners are, the county, the state, the feds even, the airport, port, and we work with all of these folks. And then we have private partners. So the Tampa Downtown Partnership, the West Shore Alliance, Tampa Electric Company, they're a major partner. And they will very soon announce a 5-year program to go from high-pressure sodium street lights to LED street lights. That's energy savings right there, sustainability. But the other thing is the new LED street lights will have networking capabilities to where we could add additional sensors to them and do things like gunshot detection. So you have these sonic devices that are picking up sounds and triangulating them if you have the right density of sensors. Think about traffic monitoring, outside of the intersection, what's going on in the bridges and things like that. Air quality monitoring. With all this growth comes air quality issues. It's good to know and correlate activity with air quality to target solutions in the right kind of way. So those are some of the things. AARP, major partners, again, they inform us from a generalist point of view. Google Waze, they're delivering some very interesting services in the mapping and mobility area to where we provide data to them on road closures. They use that data to update their algorithms. So when you use Waze, some of the algorithms are impacted by data that we provide to them. There's Gasparilla coming up. I recommend you attend. It's a big party. It's a massive party. Those of you who have been in Tampa long enough know that we get almost 200,000 people in downtown area, and it's great. But in order to manage the traffic that comes in, which is unusual traffic patterns, we do need to leverage some of these tools. Then we have V-Ride, Zipcar that T-Bar is working on, and the bike share service, which is Coast Bike. I think the bike share service here is also Coast Bike, just branded differently. I'm not certain about that though. How are we at? Okay, are we good on time?
Sure.
Perfect. All right, so let's look at some of our projects. We've got the Tampa Smart Fan project. This is a collaboration with Ohio State University, USF, private company called Intelligent Material, HART, and the Tampa Lighthouse for the Blind. This project is in early stages. We've just done the testing of the Smart Paint and all, but it is a public-private academic effort, and really, we have pavement markings, crosswalks, and things like that, right? It's basically thermoplastic or waterborne paint. So Intelligent Material has come up with a technology that can store digitized or digital information in the paint to provide certain signals based on sensors that can read it. So our use case initially is to address persons with visual disabilities, and so you have a smart cane which has a little sensor on it that can actually read the messages on the paint. And so what it does is, and this is a really short crosswalk, but if you look at large signalized intersections and you have a crosswalk, and if you are blind and totally blind, and if you're at the crosswalk, you might get to the landing pad where you have the ADA facilities and you know where the edge of pavement is and all that. And now when you go from point A to point B over a large distance, if you're even slightly askew, you're going to end up either in the middle of the intersection or you're going to end up in some place where it's not easy to get onto the sidewalk. And it might be a trip hazard and things like that. So it's a significant safety issue that the Lighthouse for the Blind told us about, and we're facilitating it with this technology. So in essence, instead of that action now, a blind person comes up there, and there's this smart paint which is blended with the pavement marking, and they will know using their smart cane what the edges of that crosswalk are, and they stay in the crosswalk. This same paint can now be used for indoor applications as well, right? Airports or convention centers. those are difficult for blind people to navigate as well. And so for the totally blind, this is a great technology. This pairs really well with, something like Bluetooth or connected vehicle technology, where you do a P2I, a pedestrian to infrastructure connection, where if this were a signalized intersection, and if that smart cane had the Bluetooth capability, we can get to a point where potentially using a P2I app, you push a button, and now not only do you know where the crosswalk is, but it also provides a signal to the, or a message to the traffic signal to activate that pedestrian phase. And now you've got, now you get closer to that vision that, I'm blind and I should be able to walk comfortably through downtown. There are 3 locations where we're going to test this technology. One is in downtown Tampa, one's at the USF campus, and the third is by the Lighthouse for the Blind in South Tampa. Again, going back to those living labs, one right here, one in downtown, and that allows us to flush out solutions better. With all of these pilot projects, failure is an option. I mean, you learn from failures as much as you do from successes, sometimes even more. You just need an appetite for taking these risks. However, this is a very promising technology. The other application of this technology is potentially really huge for connected and autonomous vehicles. So our cell phones today, they all have a GPS, right? And depending where you are in space, the accuracy of the GPS may be either a foot to up to 6 or 8 feet off, right? So somewhere from 1/3 of a meter to 2 or 3 meters off. When it comes to safety, when it comes to positioning, you can't have this kind of inaccuracy. But if the smart pane, if the smart pane could store position information that devices and vehicles could read off of, you know that you're accurate position-wise at every point. And this is really important, especially when it comes to pedestrian safety applications or bicycle applications. Think of a bicycle in a bike lane approaching a signalized intersection, and you have its position accurately to where that bicycle has a green light and it's moving fast, but there's another vehicle that's moving at 60 miles an hour approaching the intersection about 500 feet away. There's no way that car can stop, and now you're looking at a potential serious injury or fatality. Now, if you had a connected bike and a connected car, both of them know what's going on. They know what's going on with the signal, they know what's going on with the approaching vehicle, and you will avoid and prevent accidents. So that's where we're going towards. That's where this can be applied, and then there are other applications as well. Work zone safety and so on and so forth. The other is crowdsourced data, and I talked about Waze and how we use their data. We get information about incidents and traffic jams and hazards, and we provide information about road closures and flooding and things like that. So today this partnership is very nascent to where we just get a conditions report on different corridors, but the vision is to build this partnership. And again, why is this partnership key? Because more people use Waze than any app that we put together. So even if we said, let's go it alone, most people are not going to download a third app that does just one thing and you need to have it open when it is needed. Whereas everyone uses Waze, and people will use Waze even more, either Google Maps or Waze. When I say Waze, it's a Google company, so it doesn't matter which app you use, we're still getting the data. The next iteration of the Waze partnership is now you use crowdsourced data, you use other sensor data, and you have a platform that uses Waze and historical data and your ITS sensors, intelligent transportation sensors, to monitor and understand what's going on in a corridor. That would be one thing. The next step would be to plan your resources on what to do based on predictive analytics. So if, and we're actually working with an Israeli startup company called Waycare on such a platform. So you'll be able to see this platform in action about 6 months from now. But it can take information about real-time speeds and volumes from, say, a sun guide that FDOT has. It has historical crash data. It has real-time and historical special event data. And then the platform itself has other feeds as well. They get in-vehicle data from another service. In-vehicle data is very valuable. Think of, on a certain segment of an interstate, 10 cars suddenly veer left. That's great information to know before a crash happens, because there's a good chance that there's some condition, either debris or a crash or something going on in that segment, and you may not have a camera that sees it and things like that. But if you get that information from this platform and you send resources out there, if you can get medical teams out to incident sites in time, you can save lives. And studies have shown that if you get there within the first hour of an incident, or first 30 minutes, or first 15 minutes, what the difference is in saving lives. And then finally, prediction. That's where we want to go towards. With these machine learning algorithms, they can cluster different data sets, parse them, and then use them to predict what might happen. So one correlation that a traditional technician may not make is the slant of the sun or the weather combined with special events, combined with time of day, might yield certain incidents. So you can start seeing these patterns that otherwise no one entity would have been able to establish. And that's where these platforms are great. And these platforms are open, so if you have another data source, you add to it. We have another connected vehicle demo that we're working with. This is a company owned by Audi. They're called TTS. So our CV pilot, and we're going to talk about that in a second, works with sensors in the roadway. The way this works is TTS basically takes signal data from our servers at the Traffic Management Center. They publish that data to a cloud-based service. That service is then subscribed to by a vehicle. Like Audi's, if you rent a new Audi right now, they have a traffic mode, and if you're in Tampa in certain signalized intersections, it'll actually tell you when that light's gonna go red, yellow, and green. And what that does is, the simplest application of that is being aware of what the signal's doing outside of, your visual aids. The other thing is it'll give you some sort of a tone or an alarm once that 3 seconds prior to that light going green. And that really saves on delay. So many times we see people, with their heads in a cell phone, and the light goes green and they're still sitting out there. Startup delay itself is like 1.5 to 2 seconds. Add to that, I'll call smartphone delay. And that can really mess your traffic operations. So this is a way to improve safety, to get benefits, and again, the cost to the city with this, $0. And why does Audi invest in going through this entire process? It's because it makes their product better as well. Again, this is a public-private partnership with $0, just one legal agreement, and here we go. And so on a limited basis, we're testing this on 12 signals right now, or maybe 20. Not a whole lot, but if the product works well, we would definitely want to grow this service. The big limitation of this service, again, is the car communicates with the cloud-based service with what? Cellular, right? 4G LTE. So you've got that 3.5, 4 second delay. So it's not great for safety applications yet. Mobility applications, yes. Safety, we need 5G. Basically, we need less than 125 milliseconds of latency, because that's how long per spec it takes for a controller at an intersection to detect a vehicle. 125 milliseconds. So if you have latency below that, you're good. You can do a lot of things. Now, what allows us to do that? DSRC, Dedicated Short Range Communications. Fancy word for 5.9 gigahertz radios. Our wireless routers, most of them are 2.4 gig. Public safety spectrum is 4.9 gig. 5.9 gig gives you a few more channels. But right now there's a little bit of a discussion about whether 5.9 gig spectrum should belong to cell phone companies or should it be available for CV only. So this is our pilot project downtown. It's one of 3 sites, like I said. New York City is the urban pilot. We are the quote-unquote suburban because we're in the downtown area. But really, our pilot is, in my view, very biased view as a City of Tampa employee, probably the most poignant of the 3 pilots, because there are 4 or 5 New York cities, and there are 100 Tampas out there. So when you look at our size city, so what we do here really informs the country much more so than what New York City does. The other thing that is unique about our pilot is we're outfitting 1,600 private vehicles. I invite all of you to go to cdpilot.com and sign up if you either drive through downtown Tampa on a regular basis or you take the Selman Expressway. But outfitting 1,600 private vehicles allows us to track normal, regular commutes rather than using probe vehicles or taxi fleets and things like that. And that's what we're trying to address, needs of everyday people commuting from home to downtown Tampa. So most of the deployment is in downtown Tampa. We're addressing about 12 different use cases, and we're deploying over 12 apps. We're outfitting cars, streetcars, we've got the historic trolley downtown, buses, and 500 personalized devices. So these are smartphones. That's the P2I that we were talking about earlier. We are currently in deployment. We should be done with the entire deployment later this year, and then we go into the review process or observe how it works. We're using all types of equipment, but primarily you have a DSRC radio at the infrastructure level that is listening to vehicles and sending messages to vehicles. You have vehicles that are outfitted with this technology that are sending their position, their speed, their classification, things like that. And then you have pedestrians or streetcars and buses. And what services will this deliver? Well, here are the use cases that we're addressing, and here are the location, and here are all the apps that we're developing for it. One of the big challenges with this pilot, and here's why it informs the state of the practice, is the devil's always in the details, right? So when this pilot was announced, US DOT figured that, hey, we have all these apps developed and they're ready to go. We just need, some cities to deploy them, and we'll see how that goes. It's never that easy. We have 3 different vendors for onboard units. We have 1 vendor for the RSU and 3 different software vendors. Integrating all of this becomes really challenging. So before you can standardize, you really have to go through the rigor of putting all of this together. So we're working closely with the other pilots as well as US DOT to develop connected vehicle standards. And this is happening in Tampa, and this is something we should all be proud of. Here's an overview of the different locations and the apps. It's kind of busy, but it basically addresses safety, mobility for all modes of travel that we see in Tampa, with the exception of the water taxi and bicycles. Here's some of our other projects that we're looking at. So broadly speaking, intelligent sensor-based infrastructure. We're going to need sensors for all kinds of things. But I'll talk about a few of them. Smart water meters, right? Not transportation, but still public works. So we all have water meters outside our homes, apartments, dorms, whatever. These water meters were converted to digital to where you get slightly better information from them. But if these water meters communicated with the water department and communicated to a service that you can now view as an app, here's what it does. You can monitor leaks. You can regulate your own water usage. You can monitor and save water. So this again ties into sustainability as you go down. And so that's the EMI pilot, which is, AMI pilot, which is advanced metering infrastructure that the water department's working on. We look at connected smartphones. better street lights, and that's the partnership with TICO, and they should be announcing in the next few months because they're at the Public Services Commission right now. Here are some of the needs. Why do we need it? You know, clearly safety, sustainability, smart parking, things like that, and the benefits, of course. So here's another kind of high priority project that we would like to get funded and going. And that is an integrated multimodal platform. So we have many modes of transportation within downtown and West Shore or St. Pete and things like that. And oftentimes not enough information is available about these modes, and definitely not in one place. So there is a need to have a simple app that, you know, where the end user wants to go from point A to point B, and it'll tell you the best way to get there. And Google does that to some extent, but Google does that primarily with public transport, walking, driving, and maybe if there, you know, in some areas if there are other modes available, like if you go to Europe and all that, it might tell you about bike share. But for the most part, that is a need. And what this need will address is our ability to not be a single occupant vehicle on the road if at all possible and if at all convenient. The other thing that a tool like this does is it gives us excellent information. It gives, you know, transit agencies, cities, very good information because this is a user-focused tool. So not only are you, you know, delivering a better service, but you know exactly what people want. Whereas today we get that information through surveys on buses, and, you know, you're given a survey, for the most part, people try to say good things. And they don't really want to give you an accurate picture of what's going on. But if you track their actual habit in real time, there's no better information than that. So it's also for business intelligence. Smart parking, 30% of congestion during major special events is because of parking. People are looking for parking. Where is it? Part of it is because when you Google a place that you want to go to, it will take you to that place, whether it's Waze or whatever else. And you get there and you're like, okay, now where do I park? And you're moving around in circles. You can, and if you go to Gasparilla, and if you drive into downtown, you'll see we do all kinds of traffic control devices. We do cones and signs and things like that. But what we really need to do is get to a point where we can do three things with parking. One is, you should be able to reserve a parking spot before you leave, so you know that you have parking for sure. The other is, we should be able to guide you to that parking spot and not just allow Waze to guide you out there, because we may have, you know, either a road closure or some product, or there might be other background traffic. There are multiple events. And the third thing is you should be able to get into the garage really fast. And this is like a very simple math problem that we had recently with our parking manager, where we have the Poe garage in Ashley, and he was saying we're seeing congestion issues during events at the Straz and Curtis Hickson. And I was talking to the parking manager, and he says, Vic, we're meeting industry standard. We're getting cars in under 12 seconds. And the problem is 12 seconds per vehicle equals to what? About 240 vehicles an hour. The capacity of that lane, a single lane, conservative number would be what? Any guesses? About 1,400 vehicles an hour. There's your math problem. You know, it's just not going to work. So even if the industry standard of letting a car in, you know, they pull out their credit card, they swipe it, or whatever it is they're doing, we need to speed that up. And that's where technology can be useful. You know, gateless garages, and this exists. It just costs a lot of money. And you've got to make that business versus cost case and get that implemented. So we're getting to that point as well. Integrated corridor management kind of ties into the platform that I spoke about. You have a mobility platform, then you add more sensors, more awareness devices, and you improve the performance of a corridor for all modes through better monitoring, better control, and better understanding of what is going to happen, predictive analytics. And then smart pedestrian and mobility. So we talked about smart paint. Another thing we're looking at are smart beacons for indoor navigation, where you have different beacons around obstacles, and you have an app that reads these beacons and prevents persons with visual disabilities from bumping into them. And then we're looking at signalized intersection and crosswalk apps and things like that. Smart grid, another project we're working with Tampa Electric Company on. You've heard of smart grid from a security standpoint. We need to know what's going on with the grid so that if it's hacked or something happens, you're able to recover from it. The other thing the grid can do nowadays is it can transmit data along power lines. AT&T is exploring that option. And if we're able to do that, then our power lines also become our data lines all of a sudden. The other thing you can do with the smart grid is monitor power connections. Again, the same way we were doing the smart water meters, if you have smart electric meters, not only can the power company now monitor where there are sources and sinks of power, but you can regulate your own power usage on a daily basis. Now, there are external tools like Nest and things like that to do some of that. But really, if you wanted a comprehensive regional solution, you've got to go back to the utility and make sure that every network connection is in a position where you can monitor it better. And this ties into security, it ties into modernization, it ties into delivering smarter services. The smart grid also does another thing. It extends our network. So in places where we don't have fiber or we don't have other devices, we can communicate to IoT devices without having to incur costs, monthly costs, to either a Verizon or an AT&T, which allows us to manage our costs and still deliver better services at the same time. And then we're looking at electric vehicle charging, especially wireless and inductive charging. These are all unfunded projects, but these are concepts that we're working with the private sector on should funding become available. But particularly the EV charging using inductive charging. You have basically pods along a roadway, and as an EV drives over them, it's charging. So you're constantly charging. Why is this important? Because if you look at the energy marketplace, right, the traditional model for electrical energy, and it exists even today, is generate, distribute, and sell power, basically, or consume power. When you look at an electric vehicle, a very large, powerful DC motor, right? And when you look at the vehicle itself, we use our vehicles about 6% of the times. 94% of the times, they're parked. And if they're parked with a really large battery, not only can they become a vehicle when you get to work and from work, they can become an energy source when you're parked. If you have 1,000 electric vehicles the size of a Tesla battery, you can run a moderate-sized office building for 8 hours on that. What that does is it completely disrupts and changes the energy marketplace. And we go from, whoever generates the energy controls the energy to whoever trades the energy controls the energy. This is exactly what happened to the communications industry. This is exactly what's happened with entertainment, where you're seeing people that own the pipe and people that generate the content coming together because they need to do that. Now, the way it's happening in some of those industries is more monopolistic, but that's my opinion. There is an opportunity here to work with utilities and local governments to deliver public-private solutions for something like that. So, just a little bit of a plug for what we've done so far in terms of our achievements. We have the first suburban pilot in the U.S. For connected vehicle technologies. We will have the first long-term transit service using a driverless or an autonomous shuttle down Marion Transit Way. Las Vegas did come first, so this is not entirely accurate, but with the long-term part, it becomes a little more accurate. Anyway, first deployment of Smart Paint in the US, and the first partnership on the Connected Communities portal with Waze in Florida. Now, one thing you'll see other than this last piece where, you know, when you look at the partners, no one can do it by themselves. All of these services require partnerships. And again, that, if I didn't state it earlier, that is the essence or a key of the smart city as well. Where we worked in silos in the past, we now need to work together as a unit, and technology makes that easier. And here's why, because we might be different departments or different divisions, but on a roadway it all comes together. When the road is shut down and you're being rerouted, that road could be shut down because of water pipe burst, which is a water issue but becomes a transportation issue. It could be because a wastewater pipe burst. It could be a utility problem, gas line, you name it. But we're all blended together in this, and so we have to address our challenges in that context as well. So if anything, I'll leave it at that, you know, we are at a point where we're informing the state of practice on smart cities, and we look forward to participation from USF. So thank you. Any questions?
Any questions? Let's try a couple questions.
Yes, ma'am.
It's very impressed that Tampa is being a lead in this area in the U.S. And I believe I think the smart pen could be used also for autonomous vehicle as well. And so I'm wondering that many technology companies are currently doing transportation-related solutions on that.
Mm-hmm.
So I'm wondering, in all these projects, what's the government's point of role in this area? Because you have to persuade them to be partner with you, right? So many technology, I'm assuming that maybe government might be slow in some areas, so they don't want to work with you. So what's
well, so for one, I do represent the government. So the city of Tampa is government, and you're absolutely right, we're slow. That's why we need private partners. But if I understand, your question is, how do you get around the fact that government is slow to keep up with the pace here, right?
Or
and
how do you persuade the private companies to work with you? Sometimes you probably don't like to work with them.
Correct. You're absolutely right, and these are some of the challenges. I wish I had a clear answer for you, but what is emerging is, you know, of the three aspects between sensors, the network, and computing. What is clearly emerging is when it comes to the network part of things, there are more opportunities for partnerships because a lot of these network devices have to be installed in public rights of way. So if you look at the 4G to 5G conversion, for example, 5G is going to require about 30 to 100 times more devices on our streets because these are shorter distance, higher bandwidth, lower latency networks. So you're going to need a large density of small cell sites. So we're working right now with the AT&Ts and the Verizons to facilitate this infrastructure. And the minute you start working together on these things, that creates opportunities to bring in other solutions as well. So that's one avenue. The other major partners like utilities, you're finding, so most of the cities that have a request for proposal out or any kind of procurement in the smart city space is either in network communications or in utilities. So smart street lights or smart grid and things like that. So these are established partnerships that we can leverage. And the city of Tampa has had a relationship with Tampa Electric Company that spans over 105 years. You know, so these partners, so you work with who is available and who, you know, is not available right now. Well, you wait till the time is right and you work with them, but you don't let that stop you. But that's a good question. So. Yes, sir.
Yes. You mentioned 10 trolley cars in your CV distribution
Yes.
Do they run on rails?
The trolley cars, yes, they do run on rails. These are historic trolley cars. They don't exceed speeds of, I think, 25 to 30 miles an hour. Partly because it's a historic trolley, it's not a modern streetcar, so it requires a long distance to stop. But yes, these run on rails, and they also blend in with traffic as they come into South Downtown by Channel Side.
How much territory do the 10 trolley cars cover as compared to the 10 buses?
Good question. Because it's a fixed guide system, this is really a 2-mile track. And so it goes from downtown Tampa to historic Ybor City. And that's all. So it really, the way it is designed today, it's mainly for, as a tourist attraction more than anything else. But we're in the process of modernizing that streetcar to make it useful for commuters. So one of the things to keep in mind is this historic streetcar was implemented about 20 years ago, 25 years ago. That's when downtown was dead. At that point, nobody lived in downtown. After 5 p.m., downtowns were barren. And now that people are moving back into the urban core, the same facility needs to serve a different purpose.
And the last question?
Sure.
To follow up that, I heard there's an extension of the streetcar line. What is the status of that?
So, good question again. This is part of the modernization that we're looking at, and the extension is we're looking at. Currently the streetcar finishes. The last point is by Fort Brooke Garage in downtown. The potential extension is to get it up to Marion Transit Way, and maybe even further into Tampa Heights, because the downtown area is now expanding in every direction but south because it's water. But so that's part of the streetcar modernization study. We held, I think, 6 workshops last year over 2 different phases of modernization, and we do have another couple of workshops coming up. So I would invite you all to attend and find out what's going on and give us your thoughts as well.
Actually, I want to ask another question.
Okay.
I was just
Yeah.
that question is about the smart painting. I think that's a great project. And I was wondering, is that the potential conflict resolution has been done that can provide the services to the to whoever using that? What I meant was, you could kind of broadcast your location, or you can help the blind people to be sure on the track. But if the vehicle is too close to the pedestrian already, or if there's a signal timing has some delay or etc., has that been resolved that could give the warning to the pedestrians using that?
Not yet. So that has not been resolved. We've started with one application in mind, which is to keep a person with visual disabilities in the crosswalk. But the potential and the path to what you're talking about, which is making it a part of the connected vehicle infrastructure, to where, because that facility is being used, or the smart pane is being used, that there's probably a pedestrian there, and making it aware to vehicles, that's possible, but we're not looking at that yet. But that would be the logical next step. So.
Okay, let's do the last. Alright, so
Yes, sir.
last is always going on.
So most of the projects that you talked about are based in downtown, but
Yes.
as you know, you mentioned that because of historical reasons, the land use in America is different than in Europe, and people prefer to live in these huge sprawls and suburbs and stuff, rather than living in close, congested downtown spaces. So these projects are in downtown, but most people live in suburbs. So how does that figure out into your planning for the future? Do you want to move them into downtowns, or do you want to?
Good question. So really good question. 2-part answer. One is some of our projects are citywide, like all the stuff we're doing with TICO and all that. But the reason to start in a downtown area is most of these smart cities technology, and I mean primarily the networks and things like that, are all being implemented density out. You know, these are primarily city, urban-oriented technologies that are interactive, and they're harder to implement in places where you don't have that kind of density. So if you're at a Bruce B. Downs and Cross Creek, for example, you get a pedestrian maybe every 5, 6, 7 traffic light cycles. But if you go by the convention center, you've got pedestrians there all day long and all night long. So that makes it easier for us to validate, and also just the way that these technologies are being implemented, that's the place where it makes more business sense to test them. So.
All right, very nice presentation, and it's great that we see so many things that we're doing in the national frontier, and we're proud of it. And I know you have tons of questions, but our speaker actually has other agendas lined up, and let's thank him with another round of applause. You're welcome to interact with him through email